the stillness of night, when the world quiets and the sky stretches wide, a question rises from the depths of human longing. How far must we go to find another dawn like our own? Above us hangs a universe that feels infinite, a silent ocean of fire and shadow, where every star is an island, and every island whispers possibility. Yet possibility is not promise, and distance is not merely measured in kilometers. It is counted in centuries, in civilizations, in the fragile breath of hope that survives between heartbeats and horizons. Humanity stands at the edge of a cosmic shoreline, staring across a black sea without waves toward shores unseen, where life may already be watching its own sun climb a foreign sky. We have discovered planets beyond our solar system, worlds that circle other suns, worlds that may breathe, oceans that may stir with life untouched by time or memory. Among them, one lies closer than the rest, Proxima Centauri b, a world bathed in the pale glow of the nearest star to our own, only 4.24 light-years away. So close that its light reaches us in a handful of human years. So far that our fastest spacecraft would need tens of thousands of them to arrive, long enough for empires to rise and crumble, for languages to be born and forgotten, for everything we know to turn to dust and myth. We may not be alone, yet we cannot reach anyone. And in this aching contrast, in a universe overflowing with worlds, a single question haunts the human soul. If Earth ever fell silent, how long before we found another home? The stars call to us, but for now we remain anchored to one. There are moments in science when reality bends, not through imagination, but through evidence. Moments when a quiet measurement on a screen, a subtle shift in starlight, or a faint tremor in space announces a truth older than humanity itself. That the universe is not empty of worlds like ours. That planets, once believed to be the rare jewels of our cosmic neighborhood, are instead scattered across the galaxy like seeds on an infinite wind. For most of human history, the night sky seemed deceptively simple, a dome of fixed stars, distant, pure, perfect. Ancient astronomers traced patterns across the heavens, believing Earth to be the center, the single island of matter and meaning in a silent cosmic sea. Even when that illusion fell, replaced by the vastness unveiled by Newton and Galileo, a stubborn loneliness remained. Stars burned in their millions, and yet no one knew if any of them held companions. No one could say whether planetary systems were common or impossibly rare. The universe, vast and silent, refused to answer. For generations, science turned its instruments toward the heavens, seeking not worlds, but understanding, the physics of stars, the evolution of galaxies, the whispering symmetry of nature itself. Planets around other suns, if they existed at all, were beyond reach, hidden in the glare of their stars, too faint to see, too small to betray their presence. But curiosity is patient, and in the closing years of the 20th century, a quiet revolution began, one that would reshape humanity's place in the cosmos. The first break in the silence. In October of 1995, beneath the dark skies of Haute-Provence Observatory in France, two astronomers made history. Michel Mayor and Didier Queloz, armed not with loud proclamations but with data, revealed the first confirmed planet orbiting a sun-like star beyond our solar system. Its name was 51 Pegasi b. It was nothing like Earth, a gas giant orbiting scorchingly close to its star, racing around it in just 4 days. A hot Jupiter, they called it, a world whipped by unimaginable winds and scorched by fierce starlight. Not a cradle for life, but proof that planets were real, that other suns held their own families of worlds. It was the crack that split the cosmic silence wide open. Mayor and Queloz had not searched for miracles, they had simply traced the slightest quiver in starlight, a subtle, rhythmic trembling. The star itself moving, pulled gently by the gravity of something unseen. A world, invisible yet undeniable, tugging on its sun. This tiny motion, detected through the radial velocity method, changed everything. The method was elegant in its simplicity. If a planet circled a star, the star would sway ever so slightly, redshift and blueshift in its light revealing the dance. Starlight, once a tranquil beacon, became a trembling voice, and in that trembling, planets whispered their existence. The discovery was met with awe, skepticism, and then acceptance. For science demands repeatability, and the cosmos would soon oblige. One planet became dozens, then hundreds, then thousands. The universe had not been empty. It had been waiting to be seen. A new age of search begins. Following that first glimpse, astronomers around the world joined a new frontier. Telescopes scanned starlight with sharpened precision. Detectors cooled to near absolute zero listened for the faintest shifts. Computer algorithms watched for the smallest deviations, the slightest dimming, the briefest shadow of a world crossing a distant sun. In 2009, NASA launched the Kepler Space Telescope, a silent sentinel drifting through space, eyes fixed on 150,000 stars. It watched and waited for the transit, the subtle dip in light that occurs when a planet crosses its star's face. Light, once thought constant, flickered with meaning, and with each flicker came the possibility of another world. Kepler revealed that planets were not rare jewels, but a cosmic norm, more numerous than stars, perhaps numbering in the trillions across the Milky Way alone. Rocky worlds, ocean worlds, ice giants, super-Earths, and worlds stranger still. Planets bathed in red starlight, planets wrapped in eternal twilight. Planets where rain might fall not as water, but as molten metals or glass. A revelation emerged. The cosmos was far richer, far stranger, far more alive with possibility than humanity had ever dared to believe. But even as confirmation after confirmation arrived, one question rose quietly, steadily. Where is the nearest one that could host life? Where is the nearest world that could be a sibling to Earth? A whisper from the next star over in 2016. The answer arrived. Not from a distant galaxy, not from the edge of the universe, but from the nearest star to our own, Proxima Centauri, a faint red dwarf just 424 light-years away. For years, astronomers had watched it, a dim ember compared to the brilliance of our sun, flickering with magnetic storms, yet too fascinating to ignore. Red dwarfs are common, the most abundant stars in the Milky Way. If life could exist around one, the universe might be teeming with habitable worlds. But such stars flare violently, their light unstable, their radiation fierce. Could life survive such chaos? Could a planet hold on to an atmosphere beneath such restless fire? Until 2016, these questions floated unanswered. Speculation and theory, spinning in the void. Then came a discovery. Guillem Anglada Escudé and his team at the European Southern Observatory traced the faintest of wobbles, a rhythmic pulse in starlight, steady and repeatable, a signal too persistent to ignore. There, circling the nearest star to the sun, lay a world, Proxima Centauri, a planet not of myth or speculation, but one pulled from the data, teased from the trembling of starlight, just as 51 Pegasi b had been decades earlier. A world in the habitable zone, that faint ring where temperatures could allow liquid water to exist, a world roughly the size of Earth, a world that in theory could cradle oceans, could cradle air, could cradle life. The nearest Earth-like world ever discovered. Not in theory, but in reality. The cosmic ocean suddenly felt narrower. The stars did not seem so distant. A new silence settled. Not the silence of loneliness, but the hush before possibility speaks. The meaning of a neighboring world Proxima b has never been seen directly. No telescope has captured its face. No spacecraft has traced its horizon. It exists for us now as gravity and mathematics, as shifts in light and whispers in data. Yet its presence reshaped everything, because proximity carries weight and meaning. The nearest star beyond the sun does not host a barren void, but a world. And that world sits in the quiet warmth where water might flow, where chemistry might dance, where life, humble or extraordinary, might awaken. For the first time in human history, the question of other Earths was no longer a philosophical echo. It was a map point, a destination, a place within reach of imagination, if not yet technology. Proxima b became a mirror held up to humankind. In its presence, the universe felt less indifferent. The night sky gained depth, the way a lonely ocean gains meaning when a distant shore appears through the morning mist. Not alone, not singular, not an accident adrift in void. Here was proof that planetary siblings exist. And if they exist here so close, then how many lie beyond? How many circle distant suns, waiting not for discovery, but for understanding? the quiet truth beneath the triumph. Yet the discovery brought not only celebration but humility and caution. For Proxima Centauri, unlike our Sun, is a star of turbulence. Its surface boils with magnetic violence, eruptions and flares lashing space like solar storms intensified 1,000-fold. Any world in its embrace must endure constant radiation, relentless stellar wind, the ravages of cosmic weather. Life, if it exists there, would be forged in extremes, hardened by a sky that flickers with fire. But life, if it exists anywhere beyond Earth, may not be gentle. It may not resemble the familiar. It could thrive beneath oceans of ice, beneath rock and magma, in shadows where starlight barely reaches. It may breathe strange air, drink alien seas, dream beneath crimson suns. Proxima b represents not comfort, but possibility. The reminder that life adapts, evolves, fights to endure. That existence does not demand perfection, only opportunity. It stands as a testament not to certainty, but to curiosity, the force that lifts humanity from ground to sky, from telescope to starship dreams. A new era begins. The discovery of Proxima b did not close a chapter. It opened a universe. Astronomers turned their attention to nearby stars with renewed urgency. The search expanded not by miles, but by minds. Instruments sharpened, telescopes grew keener, missions were planned, and humanity's question sharpened from "Are we alone?" to "Where next?" For the first time, interstellar travel shifted from fiction to blueprint. Engineers and physicists began to ask how, not if, a craft might one day bridge the gulf between stars. How long it would take to reach that nearby world. What tools could carry the human story beyond the cradle of Earth? The turning point was not loud. There were no trumpets, no parades, no fireworks in the heavens. Instead, there was data. Cold, precise, undeniable. And within that data, a door opened. A fragile whisper pierced the silence. You are not alone in possibility. The nearest star holds a world. The universe, once silent, now speaks. From that moment forward, humanity understood that the cosmos is not a desert, but an archipelago of worlds. Some hostile, some strange, some lifeless, and perhaps some alive. The ancient ocean of stars is no longer unreachable in thought. It is a place with destinations, with neighbors, with shores glimmering faintly across the abyss. And though the distance remains vast, a truth now guides science and imagination alike. The nearest habitable world may not be a myth whispered into the void, but a real place, orbiting the closest sun, waiting across the cosmic sea. Humanity has taken its first breath as a species with neighbors. The journey has not begun, not yet, but discovery placed a compass in our hands, and the stars, once silent, now beckon. Scientific shock. A habitable promise, wrapped in danger. Discovery often arrives not as a gentle whisper, but as a paradox, a revelation wrapped in contradiction. The year 2016 marked such a moment. Humanity learned that the closest planet beyond the Sun, Proxima Centauri b, sits within the fragile band astronomers call the habitable zone, a region where temperatures could allow liquid water to pool, oceans to shimmer, and life, in some form, to take root. At first glance, it seemed a gift from the cosmos, a world almost Earth-sized, a world neither too hot nor too cold, a world orbiting the nearest star in the heavens. But in science, beauty is rarely without caution, and in the soft glow of revelation, shadows gathered. Proxima Centauri b, this whispered oasis in the dark, belongs to a world lit by a star unlike our own, a star far smaller, far dimmer, and far more violent. Red dwarfs, the quiet embers of the galaxy, do not burn with serene constancy. They crackle with magnetic fury, their surfaces erupting with flares thousands of times more intense than those of our Sun. They are common, the most abundant stars in the Milky Way, and yet their nature is tempestuous, unpredictable, dangerous. And so the first feeling that swept through astronomy was not triumph alone, but awe tinged with dread. A possible new Earth, orbiting a sun that tries to tear life from the very space around it. A world in the perfect place, around the wrong kind of star for decades. The search for life beyond Earth carried an unspoken assumption that the best chance for habitable planets lay around stars like our Sun, stable, gentle, warm. Stars that age gracefully across billions of years. Their light steady, their atmospheres calm. But Proxima Centauri was not such a star. It was a red dwarf, only about 12% the mass of the Sun, and burning a faint, fire-red glow barely visible to the naked eye. And yet around it, tucked close in a tight orbit lasting just 11 Earth days, circled a planet in the habitable zone. The shock was not that Proxima b existed, but where it existed. Red dwarfs emit most of their heat close to their surface. Their habitable zones lie tight and narrow, so close that any planet within them must cling intimately to its star. Proxima b keeps a distance of only about 7 million kilometers, mere fractions of Earth's distance from the Sun. To orbit so close to such a star is to live at the edge of hope and hazard, the storms of a red. Dwarf astronomers began to study Proxima Centauri with urgent curiosity. They already knew red dwarfs flared with volatile energy, but the true degree of chaos was startling. In 2018, instruments on Earth and in space witnessed a burst from Proxima Centauri, unlike anything seen before. A flare that brightened the star by a factor of 14,000 in mere moments. Ultraviolet radiation surged outward, capable of sterilizing the surface of any world caught unprotected in its light. This was not a rare tempest, but part of a pattern. Studies revealed that Proxima Centauri flares multiple times a day, showering its planetary system with ionizing radiation and high-energy particles. Earth is blessed by two shields, a strong magnetic field and an ozone-rich atmosphere that absorbs ultraviolet light. But Proxima b may not share these defenses. Powerful stellar wind, a stream of charged particles, could erode an atmosphere over time. Without protection, molecules break apart. Hydrogen escapes into space. Oceans evaporate, atom by atom. Imagine a world once blue, slowly losing its breath into the void. The tension deepened. A planet placed in the right orbit, yet threatened by its own sunrise. Locked between day and night to remain in the habitable zone of a red dwarf, worlds orbit close enough that gravity often locks them. A phenomenon called tidal locking. One face eternally stares into the star's fire. The other remains in endless night. On such a world, dawn becomes a fixed horizon. A line between fire and ice, between eternal storm and eternal freeze. If Proxima b is tidally locked, its environment could be extreme. A blistering dayside where air heats and rises, and a frozen nightside where atmosphere condenses and falls like snow made of air itself. Only the twilight ring, the Terminator, might hold temperate refuge. Yet hope flickers here. Climate models suggest that if Proxima b retains even a modest atmosphere, heat could circulate, softening extremes. Winds could move warmth from day to night, creating pockets where liquid water endures. Even in danger, life finds room to whisper. Life at the Edge of Starfire scientists asked a daring question. What if life evolved to endure such storms? On Earth, life thrives in places once thought impossible, in frozen deserts, within acidic pools, beside boiling hydrothermal vents where sunlight never reaches. Microbes shield themselves beneath rocks, beneath ice, beneath oceans. They survive radiation doses far beyond human limits. If life began on Proxima b, in oceans protected beneath layers of water, or under a thick atmosphere, could evolution carve out survival strategies alien to us, yet perfectly suited to a restless star? Perhaps biology there would not worship gentle sunlight but hide from it. A world of shadow oceans and twilight ecosystems, where starlight becomes something feared, not cherished. What forms might eyes evolve in a world where half the sky never changes? What rhythm would life follow, when day and night do not cycle but divide existence permanently? Speculation stirred not from fantasy, but from the resilience life displays here, on Earth. The universe, after all, has never lacked imagination. The great reversal of assumptions before Proxima b, many believed that red dwarf systems were poor candidates for life. Their violent flares, narrow habitable zones, and long periods of stellar adolescence seemed too hostile. And yet, irony has a habit of shaping science. Red dwarfs are the most common stars in the galaxy, roughly 70% of all stars in the Milky Way. If their planets can support life, the number of potential habitable worlds rises not by thousands, but perhaps by billions. The discovery of Proxima b did not simply add one more dot to the map. It redrew the map entirely. A star once dismissed became a lighthouse of possibility. A world once doubted became the closest door to another form of being. Life, science realized, might not require a sun. It might flourish in the glow of lesser stars, born not in warmth and comfort, but in struggle and endurance. The cosmos does not promise kindness. It promises opportunity. A planet caught in a cosmic trial, Proxima b sits at a crossroads between devastation and hope. To determine its fate, scientists explore models and simulations, each revealing a possibility. A world stripped bare, atmosphere torn away, surface lifeless. A world with oceans hidden beneath ice, shielded from radiation. A world with a thick atmosphere, dense enough to block deadly flares. A world where magnetic fields defy stellar wind and hold life's breath intact. NASA. Missions like the James Webb Space Telescope are designed to read the faint chemical fingerprints of distant atmospheres. Spectroscopy, the science of analyzing starlight, may one day reveal whether Proxima b carries oxygen, methane, or chemical imbalance. Signs of a living world. Until then, Proxima b remains a question suspended in darkness, and questions, not answers, are the engines of discovery. The terror and promise of proximity. The true shock of Proxima b was emotional as much as scientific. Its existence shattered distance's comfort. Before 2016, habitable worlds were hypothetical places scattered across unmeasured space. They were whispers on the far edges of telescopic sight, too distant to confront directly. But Proxima b is close, so close that future generations might aim engines toward it. So close that spacecraft plans have already begun. So close that humanity cannot look away. The nearest potentially habitable world in the universe does not rest in a gentle cradle, but in the furnace of a star that threatens to erase it. It is a reminder that creation and destruction are siblings, that life, if it exists there, must battle not over centuries, but over cosmic epochs, that survival anywhere in the universe may be an act of defiance. Proxima b's discovery taught science humility and courage. It taught that habitability is not comfort, but endurance. It taught that proximity does not guarantee safety, only possibility, a dangerous new Earth. And so the paradox stands. The closest world that might hold life circles a star that rages against it. It is a planet balanced between promise and peril, where potential oceans shimmer beneath skies scarred by radiation, where climates may freeze and burn side by side, where any life that exists would be born into struggle and sculpted by fire. It is the first stepping stone to the stars, not because it welcomes us, but because it challenges us. A message carved into cosmic reality itself. Life, if it exists beyond Earth, may not be born in gentle light. It may rise in the shadows of red suns, hardened by storms, forged by chaos. And if humanity ever reaches that world, it will not find paradise waiting. It will find truth, raw, unsoftened, indifferent. A truth that both humbles and ignites the mind. The nearest Earth-like world is not a sanctuary. It is a frontier, a question, a dare issued by the universe. In the embers of Proxima Centauri, life might flicker or fail. But in its orbit, human curiosity burns brighter than fear. And that flame, fragile, persistent, may one day guide a spacecraft across the interstellar dark toward a world where danger and hope collide beneath a restless red sun. What we have learned from light alone. In the profound silence between stars, there are no footsteps to follow, no probes to reach this far. Only light, ancient, fragile, fractured by distance, carries whispering truth. It is through this faint radiance that humanity has begun to read the secrets of another world, Proxima b, a world still unseen by any human eye, yet already heavy with meaning. Across 4.24 light-years, telescopes have watched, listened, and measured. They have gathered photons like archaeologists gathering dust from a buried city, hoping a shape might emerge. A story, a clue to destiny. From starlight alone, a portrait forms, mass and orbit. A silent dance, revealed by gravity. Proxima Centauri trembles, not by chaos, but by companionship. Each shift in the star's position, each wobble is a signature, the invisible pull of an orbiting world. From this gravitational rhythm, scientists drew first truths. Proxima b holds at least 1.27 Earth masses. Strong enough to cradle gravity, heavy enough to cling to oceans, if oceans exist. It circles its star in just 11.2 Earth days, hugging close in a hurried orbit. A year there is brief, a lifetime compressed, seasons non-existent. Yet, this proximity places it within the habitable zone, the narrow band where warmth might kiss ice into liquid water. A miracle of position, a miracle with a shadow, for orbiting so near a red dwarf comes at a price paid in radiation, uncertainty, and time. A planet of two faces, tidal locking's eternal divide gravity shapes more than mass, it shapes fate. Mathematical models suggest a high likelihood Proxima b may be tidally locked. One hemisphere, forever drowned in light, a sun that never sets, burning the same horizon for eternity. The other, locked in unending night, a silence colder than any winter Earth has ever known. Between these extremes, a frontier of twilight could form, a ring of eternal dusk, a strip of perpetual balance, where wind might carry warmth into shadow and cool into flame, where rivers could flow and clouds breathe across a world of contrasts. Here, life, if it came to be, would learn to live in symmetry and struggle, guided not by days and nights, but by gradients of survival, a planet divided yet perhaps united by adaptation. Spectroscopy, the art of reading an invisible sky. No probe has tasted Proxima b's air. No rover has rolled across its soil. And still, scientists listen. They analyze the star's spectrum, searching for tiny changes when the planet moves, when the star flares, when light filters through a hypothetical atmosphere. This is spectroscopy, the science of decoding light to reveal hidden matter. Every element writes a signature. Oxygen carves one pattern, methane another, water vapor yet another still. Should Proxima b ever transit directly in front of its star, even for a breath of time, its atmosphere might imprint its chemical identity into the starlight, a cosmic watermark, a truth etched by photons. So far, no transit has been confirmed, and yet scientists wait, instruments poised, algorithms primed to catch a whisper of life's chemistry. The Webb era. Infrared eyes on an alien shore. Then came a new sentinel, the James Webb Space Telescope. With mirrors polished like still water, with detectors tuned to infrared's secret language, Webb has begun to monitor Proxima Centauri, not through visible light, but through heat. Infrared reveals warmth, motion, chemical breath. If Proxima b holds an atmosphere thick enough to circulate heat from dayside to night, slight thermal differences may betray it. If volcanic plumes rise from surface fractures, Webb may glimpse sulfur's shadow. If alien biology exhales gases in unnatural proportions, oxygen mixed with methane, or carbon dioxide paired with seasonal shifts, these fingerprints may reach its distant eye. Scientists speak not only of searching for biosignatures, but also technosignatures, the chemical scars of industry, the artificial whispers of a civilization shaping its sky. Not expectation, not fantasy, only possibility, held with discipline, measured by data, grounded in logic, a new frontier in science, life not assumed, but testable. Storm watching, solar fury, measured from afar to understand Proxima b, one must understand the star it clings to. Proxima Centauri is no gentle sun. It is restless, a red dwarf with a volatile heart, its surface prone to stellar flares, far more powerful than those of our sun relative to size. Telescopes on Earth and in orbit monitor its tantrums. X-ray observatories track violent bursts. Radio telescopes record magnetic storms. Optical instruments measure brightness flares. These eruptions could blow away atmospheres. They could sterilize surface oceans. They could make life, once blooming, vanish like frost under flame. Yet paradox grows. Some simulations suggest atmospheres may endure if magnetic fields shield them. If volcanic outgassing replenishes lost gases, if oceans lie shielded beneath ice or cloud, there is danger, but not certainty of doom. Even hostile stars may cradle havens. In nature, life often chooses the edge of catastrophe as its birthplace. Magnetic shields, the invisible armor of worlds on Earth, an unseen guardian surrounds us, the magnetosphere, born from molten iron churning beneath our feet. It bends solar wind, deflects radiation, preserves breath and ocean. For Proxima b, that question hangs heavy. Does it have a magnetic field? Simulations diverge. Some models argue tidal locking may slow its core, its magnetic heartbeat fading. Others claim rotation and gravitational tidal forces may stir inner layers enough to sustain protection. If a magnetic field lives there, atmosphere might cling. If not, winds from the red dwarf could strip it bare across eons, unless something else protects it. Global oceans, subsurface seas, dense atmospheres, or life hidden beneath rock and ice. Nature is inventive. Life, if it exists, may hide where fire cannot touch. Atmospheric retention, models of hope and caution. Computational models, powered by modern supercomputers, play out billions of years in hours. They test atmospheres against radiation, chemistry, and stellar storms. Some show collapse, air blown into space, water lost to ultraviolet hunger. Others show survival, dense atmospheres absorbing shock, gases recycling through volcanic cycles, oceans moderating heat, cloud cover reflecting flare-borne fire. The truth, for now, lives between these futures, not a sentence, but a question. A world may suffer and still endure. Our own planet bore impacts, ice ages, mass extinctions, yet life persisted. Perhaps Proxima b is scarred, not sterile, a wounded Eden still breathing beneath its storms. Life in shadows, adapting beyond Earth's rules for centuries. Humanity imagined life like itself, basking in sunlight, walking on continents, breathing familiar air. But modern biology has rewritten expectation. Life thrives in boiling vents under crushing ocean pressure, in caves sealed from sunlight for millions of years, in radiation-bathed deserts and frozen soils of Antarctica, in acid pools and methane lakes, even within nuclear reactor waste and deep within Earth's crust. Life, it seems, does not fear extremes. It evolves to meet them. On Proxima b, if life arose, it might not bask beneath open skies. It may lurk in oceans warmed by inner heat. It may hide beneath ice, beneath rock, in twilight bands where day meets night. It may harvest chemical gradients instead of sunlight, or use radiation-resistant pigments like Earth's extremophales. It may appear nothing like terrestrial life, yet echo familiar survival. For evolution does not honor comfort. It honors persistence. Where conditions challenge existence, existence becomes ingenious. The lesson of distant light, with each photon captured. Scientists stitch a tapestry of gravity, heat, chemistry, and storm. No spacecraft has touched Proxima b. No camera has seen its oceans or deserts or frozen plains. And yet, a world is taking shape in human understanding, not by sight, but by inference. From light alone we have learned it is Earth-scaled. It lies in the star's temperate zone. Its year is 11 days long. It likely faces eternal day and eternal night. It may possess atmosphere, or scars from losing one. It orbits a star fierce and volatile. It stands on the boundary between promise and peril. This is science at the frontier. Vision without vision. Knowledge born from silence. A growing truth. There is no certainty yet. No revelation, only momentum. A gathering tide of data, refining, reshaping, sharpening the unknown. Humanity has learned to read light like scripture, to turn spectra into landscapes, equations into climates, starlight into possibility. And possibility is powerful. For in every photon from Proxima Centauri, there echoes the same idea. Life does not need Earth to happen. Life may follow rules yet unwritten. Life may rise not despite adversity, but because of it. Even in the glare of a hostile star, a world might dream. Distance as a wall against hope. Across the quiet gulf of space, there are distances that do not merely separate, they humble. Proxima b, a world that stirs imagination, that whispers with the possibility of alien dawns, lies only one star away by cosmic standards. Yet in human terms, it hangs beyond the horizon of attainable reality, 4.24 light-years, a number easily spoken, yet incomprehensible in magnitude. Nearly 40 trillion kilometers of emptiness, a void so large that even light, the swiftest traveler in existence, takes more than 4 years to cross it. Here, distance ceases to be a measurement. It becomes a barrier, ancient, silent, and indifferent to yearning, a journey measured in human lifetimes. And lost to them in the 1970s, humanity flung its first messengers into interstellar space, the Voyager probes. Today, Voyager 1 drifts outward at about 17 kilometers per second, a triumphant relic carrying music, mathematics, and hope on a golden record. And yet, if it were aimed at Proxima Centauri, it would not arrive for more than 75,000 years, 75 millennia, longer than recorded human history, longer than civilizations, languages, and empires endure. New Horizons, once racing past Pluto, pushes space at nearly 15 kilometers per second. It too would need over 80,000 years to reach that neighboring star. Technology that once felt like triumph now reveals a humbling truth. Humanity has barely taken a step beyond its cradle. Speed, a dream. Humanity cannot yet command even. The boldest engineering proposals whisper the same limitation. Nuclear fission rockets, engines born from the same fire that powers our submarines and power plants, promise improvements measured in factors, not revolutions. With them, the journey might fall to thousands or tens of thousands of years. Still too long for spacecraft to remain healthy, for systems to resist radiation and dust, for memory and purpose to persist across epochs. Fusion engines, though studied in laboratories, remain aspirational, requiring containment of plasma hotter than the sun itself, a physics frontier humanity has not yet mastered. Antimatter drives shimmer in equations and theoretical papers. Their fuel the purest form of energy known, but generating antimatter in useful quantities remains beyond current capability. A gram costs billions, a kilogram remains as mythical as starlight in a sealed cave. Across every scenario, optimism bends before physical law. To cross interstellar space is not like crossing oceans or planets. It is like crossing time itself. The fragility of machines in eternal night even. If propulsion were solved, a second obstacle rises: endurance. Space is not empty. It is a sea filled with unseen dangers. Cosmic rays, charged particles hurled by supernovae, micrometeoroids, smaller than sand, but striking with the force of bullets at interstellar speeds. Drifting clouds of gas and dust capable of eroding metal, frying circuits, and wearing down even the most hardened armor. A spacecraft crossing deep time would face millions of years of radiation damage, electronics aging into silence, materials slowly atom by atom torn away by collisions with interstellar dust. And beyond all engineering lies another truth. Memory fades, software corrupts, hardware decays, mission purpose dissolves in cosmic weather. To reach Proxima b, a machine must not only travel fast, it must endure ages without repair, without guidance, without faltering. Today, no technology exists for such resilience. Humanity builds machines to last decades, not millennia. Biology, a candle in the cosmic wind. If machines struggle against eternity, life fares worse. Human bodies are sculpted for Earth, its gravity, its air, its shielding magnetic embrace. Beyond this cradle, radiation gnaws at DNA. Muscle fades without gravity's pull. Bone thins like desert wood under empty sky. Even in the nearest future's most advanced starship, humans would step into interstellar space like fragile seeds cast into storm. Cryogenic sleep, the ancient dream of drifting frozen between stars, remains a fiction. Cells rupture when ice forms. Neurons forget identity. Organs do not wake simply because time has passed. Generation ships, vast arcs drifting for centuries, face paradox. Their populations must survive not only biology and engineering, but sociology, culture, purpose. No society has ever remained unchanged across centuries, let alone tens of thousands of years. To plant humanity into such a vessel is to cast civilization into uncertainty and hope it remembers why it sails. Distance as despair in the vast ledger of the cosmos, Earth has only just lifted its gaze. Humanity stands on the shoreline of an ocean without end, a shoreline lit by curiosity, yet bordered by overwhelming scale. The nearest potentially habitable world may as well be infinity away. Knowledge, for all its wonder, brings melancholy. Proxima b feels simultaneously close enough to touch and impossibly distant. A lantern seen across a ravine no bridge can yet cross. A whispered promise just beyond reach. It is the agony of discovery. To find a world that could reshape destiny, and realize that current strength cannot claim it. There is a loneliness in this understanding, a quiet ache woven into scientific triumph. For in knowing Proxima b exists, humanity has glimpsed both hope and limitation. And yet, stars have never feared time. Though despair lingers, it does not reign, for the universe is vast not only in distance, but in possibility. Human history is short. Human imagination is not. Where physics offers walls, innovation seeks windows. Where the void stretches endless, ambition kindles engines yet unbuilt. Light sail concepts, break through starshot, driven by laser beams. Dream of tiny craft racing at 20% the speed of light, reaching Proxima Centauri in mere decades, not ages. Their payloads would be small, their courage immense, their journey a spark of human will hurled into the night. Matter annihilation drives, warp metrics, and space-time geometries remain ink on paper, yet every equation carries the same whisper. What is impossible today is only waiting for a different tomorrow. Humanity has crossed oceans, mountains and planets, not because it was easy, but because distance, eventually, always surrenders to persistence. A quiet truth. Beneath the weight of stars before Proxima b, the nearest dream of another Earth was distant enough to be fantasy. Now, there is a real world nearby, close enough to measure, close enough to imagine finding oceans or continents or twilight forests, close enough to inspire machines and minds still unborn. And so the paradox stands. The nearest alien shore lies farther than current life can travel. But no frontier stays untouched when curiosity burns. Distance is a wall, but walls have always been invitations in disguise. Across 40 trillion kilometers, beyond radiation, dust, time, and uncertainty, there may be life waiting, or silence deeper than any human night. No matter which truth awaits, the journey begins not with engines, but with longing. And longing has never been defeated by distance. Paths toward a new sunhope has never been gentle in its demands. It asks civilizations to dream beyond what nature allows, to look toward unreachable horizons and whisper, not yet, but soon. Proxima b lingers in the collective imagination like a second dawn, a quiet world circling a faint red ember, close enough to measure, far enough to ache for. To reach it, humanity must reimagine motion itself and bend centuries into stepping stones across the void. Here begin the theories. Not fantasies without grounding, but scientific strategies, embryo ideas forged in equations, laboratories, and the fierce patience of physics. Each is a doorway into tomorrow, a question placed before the cosmic frontier. How does a species leave its cradle and claim the universe beyond? Light pushed by light, the laser sail. Dream among the most daring visions is one that forgoes fuel entirely. Not rockets, not propellant, only photons. Breakthrough. Starshot, a project born from Nobel minds and bold capital, a plan to send wafer-sized spacecraft into the night at 1/5 the speed of light, nearly 60,000 kilometers per second, using the pressure of light itself. A gigawatt array of ground-based lasers would focus upon a thin reflective sail, no larger than a human hand, no thicker than a whisper. Light, in endless acceleration, would push these tiny emissaries into relativistic flight, crossing the chasm to Proxima Centauri in 20 years, a blink in cosmic time. But the beauty in this concept hides razor-sharp hardship. To accelerate without burning through, a sail must survive unimaginable stress. To aim a laser across atmosphere and Earth's rotation requires precision beyond current reach. And once free, how does a craft no heavier than a feather communicate across 4.24 light-years, powered only by starlight and ingenuity? Challenges pile like dust on the edge of eternity. Beam diffraction, atmospheric interference, signal strength weaker than a falling snowflake heard across continents. And yet, this is not dream-scribed fiction. Laboratories test photon sails today. NASA models interstellar comlinks. Optical physicists refine lasers that neither shake nor tremble. The first expedition across the cosmic sea may not be a ship of steel and crew, but a needle of silicon bearing humanity's silent ambition, piercing darkness with the light that forged it. Engines forged in stars, fusion and the fire of creation. Beyond light sails lies a path older than civilization itself. Fire, but not the gentle combustion of chemical engines, not even the violence of fission that split the atom's core. Here, imagination turns to fusion, the same nuclear alchemy that powers stars. Projects like Daedalus and Icarus exist as blueprints for vessels that would ignite fusion pellets, expelling plasma like the breath of a controlled supernova. These machines, kilometers in scale, could accelerate atomic fuel into thrust and cross to Proxima in 50 to 150 years, a journey within the arc of human lifetimes. Such concepts call upon engines that pulse like beating hearts, billions of controlled nuclear bursts guiding humanity across silent eons. Yet the realm between theory and reality is vast. Sustained fusion remains elusive even within Earth's reactors. Containment demands magnetic fields that bend like glass under pressure. Propellant mass grows staggering, gathering helium-3 from moons, gas giants, or hypothetical mines drifting in deep space. But fusion's promise lingers. It offers endurance, self-contained power, and propulsion drawn from the same physics that light galaxies. If humanity learns to tame the fire of stars, interstellar space will no longer be an ocean. It will be a highway. Riding the thunder. Nuclear pulse propulsion. There exists a design so bold, so fierce in pragmatism, that it reads like myth. Project Orion, a starship driven by successive nuclear detonations behind a shock plate, a vessel pounded forward by controlled apocalypse. In theory, such propulsion could accelerate massive ships to a few percent of light speed, a voyage measured in centuries, not millennia. Humans aboard might see Proxima in distant generational memory, but physics is not the only judge. Ethics and treaties weigh heavily. The void between stars would shake with the thunder of bombs. To build such a machine is to weaponize hope, and the line between journey and jeopardy grows razor thin. Still, the concept lingers in aerospace vaults and scientific memory, a reminder that ambition is rarely gentle, and sometimes the path to stars demands uncomfortable truths. Antimatter, the perfect fuel locked behind impossible scarcity. If energy is the currency of interstellar travel, antimatter is the universe's most extravagant fortune. When particle meets antiparticle, matter erases into energy, complete, brutal, pure. A starship powered by antimatter could approach meaningful fractions of light speed, reaching Proxima in decades. Yet reality draws its limits. Human technology has created nanograms of antimatter, at cost rivaling nations. To power a starship, grams are needed, a difference so immense that it might as well be myth. Storage remains an equal challenge. Antimatter touches matter and annihilates instantly. A fuel tank must levitate its contents inside electromagnetic cages, suspended like lightning caught mid-flight. Antimatter propulsion, for now, is the dream locked inside the laws of physics, waiting for a civilization yet unborn. Generation ships, civilizations between stars. Some visions seek no speed, only time and fortitude. Generation ships, vast self-contained worlds, drifting for centuries, where families are born, live, and die in the shadow of a journey none began and few will see completed. Inside these sealed ecosystems, nature would be simulated, culture preserved, or transformed. Biology would adapt, society might evolve beyond remembrance of Earth, creating beliefs shaped not by continents but corridors of steel, not by sunsets but by the hum of oxygen processors. What returns to a distant star may not be what departed human shores. A species traveling across centuries may step onto alien soil as strangers to the world that birthed them. Such missions ask a question beyond science. Is purpose inheritable? Can motivation survive generations separated from origin? Is humanity a biological lineage, or a memory carried by will? Cryosleep, wintering through the void. Another vision imagines stillness, a human body lying quiet in suspended time. Organs slowed, cells protected, a heart waiting to wake in another sun's morning. Cryogenic stasis has touched science. Organ preservation, induced hypothermia in medicine, laboratory cryobiology, and yet whole organisms, complex, fragile, conscious, resist sleep beyond natural limits. Ice crystals tear tissues, brain function fades without warmth, identity dissolves under time and cold. To freeze a human for centuries is not yet life, but a fragile surrender to entropy. Ethics. Echo. What does consent mean when time swallows memory? What value does a life hold, pause between worlds? Can a dreamer frozen in hope ever truly wake whole? Science edges forward but remains humble, aware that life is not a machine to be switched off and resumed. Warp space, the impossible, that physics has not yet forbidden. There remains one final frontier, written not in engineering blueprints, but in space-time geometry. In 1994, Miguel Alcubierre proposed a metric within Einstein's relativity, a bubble of space-time contracting before a ship, expanding behind it, allowing travel faster than light without breaking light speed itself. A warp drive, not fantasy, but mathematics. The barrier lies not in physics, but in energy. Negative energy, exotic matter, quantum fields stretched beyond known limits. For now, requirements exceed cosmic scale, yet each revision trims the impossible. Each paper edges theory toward feasibility. No law forbids space-time from bending to will. Only practicality does. Today, warp engines sit beside alchemy in the library of possibility. Tomorrow, they may sit beside aviation and electricity as marvels that once lived only in speculation. The universe rewards the patient. The bridge to Proxima b is not yet built. Its beams are equations, its pillars experiments, its foundation a stubborn refusal to accept isolation. Throughout history, every impossible boundary, the speed of sound, the gravity of Earth, the vacuum beyond sky, fell not with ease, but with relentless time. The cosmos demands patience, and humanity, though young, has shown patience measured in curiosity and persistence. Perhaps the journey to another sun begins not with rockets, but with a species learning to wait, to innovate across generations, to mature into a civilization capable of holding stars in its sight without despair at their distance. For Proxima b is more than a destination. It is a question. Is the universe meant only to be observed, or eventually inhabited? One world away, a silent planet orbits a quiet red star, waiting, not inviting, not promising, only existing. A reminder that possibility does not guarantee triumph. Preparing to cross the cosmic ocean beyond the familiar warmth of the sun, beyond the whisper-thin shell of the heliosphere, lies a sea without currents and without wind, a cosmic ocean where stars drift like ancient lanterns, suspended in a tide of darkness older than time's first breath. And humanity, standing at the shore of this impossible expanse, prepares its tools, not yet a ship to sail that ocean, but instruments to study its depths, to read its currents, to dream its roots. For every great voyage in history, before wood touched water or canvas caught the wind, there were maps, charts drawn by patient minds, lines etched by curiosity. Now, as the dream of interstellar travel flickers like dawn on the horizon, humanity gathers its maps again, cosmic and quantum, fragile and magnificent. The journey to another star has not yet begun, but the preparation has. In the silent reaches of Earth's orbit, a mirror of gold floats like a fragment of a fallen sun. The James Webb Space Telescope, delicate and patient, stares across light years to decode the breath of distant worlds. Its instruments study atmospheres that no human has touched, hunting for carbon dioxide, methane, water vapor, for the faint chemical size of biology. On worlds circling faint red dwarfs, or bathing in the mild glow of sun-like stars, Webb listens. Each spectral line a clue, each photon a messenger from a world we cannot reach. Not yet. It is a scout without motion, traveling not through space, but through understanding, closer to Earth. TESS, the transiting exoplanet survey satellite, sweeps the sky in wide arcs, cataloging worlds like a cosmic census taker. It watches stars dim, not by chance, but by the passing shadow of planets. A flicker, a dip in starlight, and suddenly, a world is known to exist. Cheops refines this vision, measuring planets with the precision of a jeweler studying diamonds. And on mountaintops, where the air thins and the world falls away, the European Extremely Large Telescope takes shape, a giant eye waiting for night, ready to see continents of alien planets and resolve clouds on their distant horizons. These are not ships, but they are compasses, sextants, telescopes once again at the bows of caravels not yet built. Every spectrum captured, every planet confirmed, sharpens humanity's map of the future. Before crossing oceans, sailors learned to read the stars. Now, scientists learn to read the atmospheres of other suns. Yet, understanding alone is not enough. The ocean of space is hostile, indifferent, governed by physics that show no mercy to flesh or metal. Before crossing it, humanity must solve not only distance, but endurance. At high-energy laboratories, particles collide with the fury of newborn stars. Here, in rings of steel and superconducting magnets, humanity asks forbidden questions. Can energy be harnessed more deeply than fusion? Can propulsion borrow from the quantum? Is there a door in physics not yet discovered, waiting only for the right question? From CERN to plasma reactors, engineers shape magnets and magnetic bottles that may one day imprison starfire itself. For fusion is not simply a dream of endless power. It is a dream of motion, of engines burning hydrogen stolen from the void, pushing starships with the steady patience of suns. In clean rooms gleaming white, solar sails unfold like metallic wings. Ultra-thin films tested under vacuum, nudged by photons, learning to ride light as ancient sailors learned wind. Small prototypes circle above Earth, moving not by fuel, but by pressure from sunlight alone. Primitive now, but prophetic. A technology waiting for lasers more powerful, materials more patient, ambition more daring. To cross light years, humanity may one day ride starlight itself. Radiation, the invisible predator of deep space, lurks in silence. Charged particles streaming from cosmic accelerators, supernovae, pulsars, black holes, strike like spears against flesh and circuit. So instruments drift beyond the planet's magnetic cocoon, counting every strike, measuring every ghostly particle. Solar storms lash spacecraft, revealing shields weak and strong, guiding engineers to stronger armor and safer designs. For to send a crew without protection would be to send them into a slow storm of death. And so the radiation is studied as sailors once studied the patterns of hurricanes, knowing that survival begins with knowledge of the threat. Humanity also tests communication for distances that strain imagination. Entangled photons flicker in laboratories, hinting at messages shared without crossing the void. Quantum experiments ache toward a future where information defies the tyranny of light speed, not in violation of physics, but by embracing deeper laws. Whether this promise will one day whisper across parsecs remains unknown. But once again, humanity practices, preparing instruments before daring the voyage. Meanwhile, robotic emissaries leave the cradle of the solar system. New Horizons, once a visitor of Pluto, now drifts outward through interstellar dusk, its instruments tasting the edge of the sun's fading breath. Voyager 1 and Voyager 2, ancient by machine standards, carry memories of Earth engraved in gold, drifting in silence through a darkness that grows richer with every kilometer. They are not fast enough to reach another star, but like trail markers carved into trees at the edge of a wilderness, they show that departure is possible. That space does not reject humanity, it merely waits. Ahead may lie a chain of stepping stones, missions to Kuiper Belt worlds, then to the Oort cloud, then to the deep between stars. A slow outward crawl, each mission reaching farther, each probe learning lessons that its successors will master. Civilization rarely leaps into the unknown. It advances by patient increments, each step small, each dream large. Inside vast climate-controlled chambers, life support systems hum with sterile precision. Closed-loop ecosystems recycle air, purify water, grow food under artificial suns, not as novelties, but as practice, crafting gardens that may one day bloom in vessels traveling decades or centuries in the dark. Biologists study the effects of isolation, of time, of radiation on tissue and cell. Cryogenic research pushes limits, learning how life responds when time slows, how biological machinery endures cold that would freeze oceans solid. Cryosleep remains beyond reach, not myth, but an ambition suspended between biology and engineering. Yet the research does not cease. For to sleep through centuries would be to cross time as well as space, to become passengers in frozen stillness, waking beneath a foreign star with memories as fresh as departure. If the body can one day slumber, then the journey may become less a voyage, more a dream between worlds. Across all these efforts, humanity prepares not only technology, but itself. Psychologists model minds stretched across centuries. Sociologists simulate tiny populations living in artificial societies, studying culture under confinement, identity shaped by isolation. meaning formed without horizon or home. For a ship crossing the interstellar dark would be more than metal and fuel. It would be a world unto itself, a seed of civilization carried through emptiness. The travelers would not simply go to another star, they would become something new along the way. Such questions are not engineering challenges, they are philosophical ones. What does it mean to be human when Earth is a memory? What identity survives when generations live knowing their destination lies beyond their lifetime? What hope anchors souls who will never see sunrise on the world they travel toward? These inquiries form a compass as vital as any star tracker, for the greatest voyage in history will require not only navigation of space, but navigation of purpose. Every telescope launched, every particle accelerated, every insulation panel tested in cryogenic chill is a quiet declaration. The universe will not be reached in a rush, but it will be reached. Patience becomes propulsion. Curiosity becomes fuel. Failure becomes apprenticeship to the stars. Humanity builds its compass long before it builds its ship. And so, in laboratories and clean rooms, in observatories perched upon ancient mountains, in code written by tireless minds, in metal shaped by silent machines, the future forms grain by grain. The cosmic ocean waits, not impatiently. Stars do not hurry, and time is their servant. The tools grow sharper, the maps grow clearer, the dream grows nearer, for one day, perhaps not soon, perhaps not in haste or triumph, but in quiet determination, a vessel will leave Earth not to orbit, not to wander the solar frontier, but to cross the gulf between suns. On that day, it will carry not only technology, but legacy. It will carry the silent hopes of all who ever looked at the night sky and saw not darkness, but destination. For every great crossing begins long before the sails are raised, in the patient gathering of knowledge, in the forging of tools, in the understanding of the world left behind and the world not yet reached. Humanity is preparing, and the stars are watching. In the hush of twilight, when the world lies quiet beneath the fading glow of day, a simple truth settles over humanity like evening mist. The nearest Earth-like world may circle a star just beyond sight, only 4¼ light-years from home, and yet it might as well be infinity away. Proxima Centauri, a red dwarf ember in the cosmic night, 3 planets turning in its faint light, one resting in the fragile grace of the habitable zone, a world where seas may shimmer, clouds may drift, winds may whisper across soil that has never known the weight of thought, so close that its starlight reaches Earth in the span of a breath in cosmic time, so distant that even the fastest human creation would take tens of millennia to arrive. This is the paradox of our age. The universe has revealed its doors, yet the threshold remains untouched. Stars beckon like lanterns hung across a dark ocean, and humanity stands barefoot on the shore, watching waves that cannot yet be crossed. For countless generations, the night sky was a ceiling, a dome painted by myth, stitched together by gods and legend. Now it is a map, a vast geography of suns and worlds, measured not in miles or kilometers, but in time itself. Distance becomes a story not of space, but of eras. A journey to the nearest star with current technology would outlast civilizations, languages, even memory. Cultures rise, flourish, fracture, and fall in less time than a single interstellar voyage would require. A species may learn to split the atom, build cities of glass and steel, cure disease, create silicon mines, and yet still be tethered to the same cradle of origin, watching the same familiar sunrise that has warmed every ancestor who ever lived. The universe is grand enough to hold gods, but humanity is still in its infancy. Like a child standing at the threshold of a great cathedral, awe floods the senses, yet footsteps remain unsure, not because the way is barred, but because understanding is young and courage must grow at the pace of wisdom. Across the epochs of Earth, ambition has always outpaced ability. It is a trait carved into bone, written in genome, whispered through myth and science alike. Humanity desires horizons it cannot yet reach. The first humans stared across oceans they had no ships to cross. They carved boats from trees, tamed currents, learned the stars, and claimed new continents. Polynesian navigators crossed the Pacific, guided only by sky and swell, long before compasses or clocks. Great caravans braved deserts that seemed endless, following celestial patterns like sacred script. Every impossible frontier has eventually become familiar. Every once infinite expanse has yielded to patience, learning, and will, and now the only horizon left is written in starlight. Yet this horizon is different. It stretches not across geography, but across time. It demands more than oxygen and heat and fuel. It demands generations. The true barrier between stars is not space. It is endurance. It is continuity. It is belief sustained across centuries, carried like flame through the long night between worlds. To yearn scientifically is not to hope blindly, nor to dream without discipline. It is to build telescopes instead of temples, observatories instead of altars. It is to replace prophecy with data, prayer with propulsion theory, longing with laboratory precision. Hope, in this age, has become a technology. Equations rise where legends once lived. Spectral signatures replace whispers. Star catalogues supplant constellations drawn by mythic hands. Yet beneath the mathematics, beneath the simulations and mission studies and propulsion prototypes, the ancient human hunger remains unchanged. A desire to go farther than breath has ever reached. To find companionship in a universe that feels eternally silent. To stand under a new sky and recognize, in that first alien dawn, the echo of every sunrise seen on Earth. For science is not merely the pursuit of knowledge, it is the architecture of longing. It is hope disciplined by understanding, and hope is propulsion. Some imagine a future where humanity remains tied to its home forever, not imprisoned, but content, tending one world like a sacred garden, mastering its seasons, healing its wounds, growing roots instead of sails, a noble fate perhaps, peace built not through conquest but through stewardship, wisdom choosing presence over reach. Yet worlds are fragile things. Stars age, planets change. Even the most stable cradle will one day cool or burn or quake beneath forces older than life itself. To remain children of Earth is to accept that one day the story may end where it began, on a single blue world, bright and brief in the cosmic night. Others imagine a different path, a future where humanity becomes a species not bound by ground or sky, but carried by curiosity across interstellar dark, citizens not merely of a world, but of the cosmos, not conquerors but caretakers of knowledge, pilgrims of starlight, witnesses to the vastness that gave birth to life and possibility. For in every direction, the stars call, not with demand, but with quiet invitation. Between these futures lies a question older than science and younger than time. Is existence defined by where life is born, or by where it chooses to go? Every sunrise on Earth is a reminder. Light travels from a star to touch a world, and in doing so, binds them. One day, perhaps far beyond memory or prophecy, another world will turn beneath another sky. And on that world, beings shaped by time and journey may stand at dawn, watching the first rays of a foreign sun crest an alien horizon. Whether they are human in form or only in spirit, they will carry with them the echo of this world, the cradle that dared to imagine more than survival. They will know that light can reach across emptiness, and so can life. They will greet their dawn not as strangers lost in the void, but as heirs to a lineage that began when the first consciousness looked upward and asked why. And in that moment, the distance between stars will not feel like separation, but continuity, a thread stretched across epochs, binding ancient seas to alien horizons. For now, humanity stands at the threshold, neither grounded nor ascended, a species between eras, caught in the quiet breath before movement. The stars do not hurry. Galaxies wheel in majestic silence. Time is generous to those patient enough to learn its language. Humanity is learning. It maps atmospheres of distant worlds. It builds engines that whisper of future fire. It studies biology at the edge of its endurance, physics at the edge of reality. It dreams in spectra and equations, in heat shields and sails of light. And though the destination is unimaginably distant, the journey has already begun, in knowledge, in intention, in the quiet certainty that standing still is a choice life has never made for long. Every civilization must someday choose to remain where it began, or to follow the urge older than breath, to wander. The universe is silent, but not empty, wide, but not indifferent, distant, yet welcoming to those patient enough to approach with reverence instead of haste. In that vastness, humanity is small. But small is not insignificant. A spark is small, yet given time, it becomes a star. And so the question that lingers is not whether humanity can cross the cosmic ocean, but whether it will decide that the voyage is worth the centuries it demands. For the greatest journeys are measured not in distance, but in purpose. And purpose lives in hearts that dare to look beyond the familiar shore and see not darkness, but potential. One day, perhaps far beyond the memory of today's world, a voice may speak beneath an alien sky and say, "We came from a star long ago," and that world will listen, not as a stranger, but as a destination fulfilled, as a promise kept across light years and lifetimes, as dawn witnessed by those who refuse to let night define the limits of their reach. Until then, every sunrise we see is borrowed from a single star, a reminder of origin, a whisper of destiny, and somewhere beyond the edge of sight, another sunrise waits, unseen, untouched, yet inevitable. For the universe does not rush its stories, and humanity, newborn in cosmic years, is only beginning its first chapter beyond the cradle of Earth. The stars are not beyond reach, only beyond impatience, and one day, when the time is right, a distant world will watch its own dawn rise, and know that across the gulf, a tiny blue planet once looked up and dreamed itself into the heavens. The journey has not yet begun, but the destiny has already awakened.